Every engineer wants to be as productive as possible. That's true. We want to get rid of errors and costly mistakes in our workflow. At the same time, we want to get rid of annoying work, like doing something which can be done only once and maybe reused in the future. But besides that, we are forced to do some routine tasks, not only designing, but such as BOM calculation, drawing generation, CNC program generation, and so on. I'm Igor, Sales and Support Engineer of Woodwork for Inventor team. Today I'm gonna show you how iBox feature of Woodwork for Inventor can help you to be more productive in your daily workflow. First of all, let's take a look at the usual workflow, what we do on a daily basis, and then we will see how the iBox can improve your daily workflow. Everything starts from the task, which the manager gets the request from the customer, sends to the engineer. Once these requests have been sent, engineer starts to design components. In most of the cases, if we are working with traditional workflow, it starts to make them individually, one after the other. When the component have been made, this component is placed to some other assembly. And in such a way, design workflow happens. As you may see here, we have such a disadvantage that those components are not related with some general concept. They are standalone, which means that if there is a need to make any changes, it's very hard to do them. We basically need to change each individual part of each individual components, which in fact requires a lot of time and efforts. So once this routine task is completed, we need to produce some data for manufacturing, which includes the BOM, drawings, nesting, and the CNC. In more complex case, this can require some additional steps, but this is like very basic data workflow. Once we get all this, it can be sent to the workshop in order to produce the items that we have designed. In more complicated cases, the manager cannot estimate the prime cost for the customer. So that's why some engineering work needed to be done before we can say to the customer how much this furniture will cost and if he agrees to make it in our company. So that's why after BOM calculation, which in most cases is made in a manual workflow, this BOM is returned to the manager in order to get his approval about that this BOM fits customer requirements and we can go on with next steps. However, in some cases, some changes will be needed. And as you remember, it's done manually. So we need to update our components, we need to update our assemblies, and then if the BOM fits customer's requirement, we can go for the next steps as drawings, nesting, and the CNC. As you may see, the workflow of an engineer includes not only design, but it also includes some routine tasks which should be done. So how the company solve this problem? They hire more staff. Different persons for different tasks. It may look like a clever idea. However, it's not, for a very simple reason. Because when we send the data from one person to the other, it's very hard to do this. You need to explain the other guy what you want, what you have in mind. And also it may occur that after some step you have some mistakes. And nobody will notice that until the data reach the workshop. So nobody knows at what chain member this error happened. That's why we get wrong final results. And it's a very hard situation to fix. In some cases, if somebody in this long chain cannot do his work, maybe is ill or something, this chain breaks. What we can see in this traditional workflow? We can see that design task took about 30% and the remaining 70% is used for data preparation for manufacturing, which is very sufficient amount of time. So everything changes when Woodwork comes into play. And now we will see how it changes this behavior. Later on, of course, we will see more details about iBoxes. But let me finish this theoretical part. Let's compare the workflow what we have in Woodwork for Inventor. First of all, we start our design from the skeleton, wherever it would be. Is it a box or is it some cabinet? It's not really important. When we have our parametrical skeleton, we start to dress it with the panels and finally we make an assembly. Then we assign materials, place the hardware in order to make right holes and right calculations. And finally, when we have this model in a final state, we place it in our main assembly, in our concept. Let's say that it took such amount of time. However, if we will focus on the step when we already have materials and hardware, we may think, okay, I have a cabinet and maybe I can use it in various concepts. Somewhere it fits in the kitchen, maybe it fits like a standalone cabinet in other assembly, and so on. Why not to use it once again? And that's the right question. Basically, the iBox idea is that we can create our design concept and then we can use predefined items, wherever it would be, cabinet, drawers, and so on. Instead of having a need to design everything from scratch each time, we can just utilize predefined assemblies. Okay, now let's see what happens in the workflow. So first of all, engineer focuses on idea, what we need to build. And this idea is discussed with the manager. When this idea is clear, when the manager agrees that this is like a good solution for the customer, then we start to add some details. Okay, we start to put those iBoxes inside of this general layout. Moreover, because of Woodwork for Inventor, we can get all necessary manufacturing data automatically from this conceptual model with iBoxes inside, which means that we can easily generate BOM, easily estimate the prime cost, which again can be sent to the manager, and if he agrees that everything is fine, in just a few clicks of a button, we can get drawings, nesting, and the CNC codes, which again can be sent to the workshop. So now let's see this picture. If our engineers are able to not only design but as well produce BOM, drawings, nesting and CNC very easy, so that's why instead of expanding our staff by various competent persons, we can just hire more engineers. Now let's see the Woodwork for Inventor workflow. First of all, what we get immediately at least is like 50% time saving. It depends on how various your furniture is. If it's more or less standardized, then we get even more benefits from this workflow. But what makes this unique is like the remaining time is spent mostly for the design, and only a fraction of this time is spent for the manufacturing, which is very, very important for us as engineers. Every one of us likes to design something, nobody likes to sit with the calculator and do some calculations about how much material we need to buy. Okay, now let's see how this is achieved. And of course, because our topic is iBox, as you understand, this is like the iBox benefits. Now let's see what is that. So first of all, the iBox is predefined parametric assembly of different size, but it have the same topology. It means that, for instance, if we have drawers, they can be different by the shape, by the size, but basically inside of it we have the same structure. So as an examples of iBox, we can say that we can design drawers, cabinets, doors, facade, some cases, and so on. So we are not limited on only something rectangular, it can be something more advanced. It depends mostly on your design. Now let's find out how it works. So first of all, we have a generalized concept. As you can see, it can be very simple, which basically is like a multi-body part placed inside of an assembly. And what happened next, we just place some iBoxes inside of this concept. In order to do this, it's enough to just mark some geometry. So when we define what component will be placed, the assembly copier works in the background. So assembly copier copies the assemblies with their components, and then when the file is inserted in our assembly, basically we need to show where is the reference geometry for it. So in this case, I need to mark the top, the front, and the side of the cabinet, for instance. And what happens next, Woodwork measures the size of a box and then sends those parameters to our model, which of course causes it changes. Okay, so what next? In the same procedure, we can basically place a lot of those iBoxes in our concept very easily. So we just repeat the same steps again and again until finally we get our model at the necessary level of details. So it doesn't take a lot, and if you find out that something is wrong with the concept, we can easily fix it by just removing one iBox and placing the other one. As you may see, such a workflow, we can get such things like kitchens, some standardized furniture very easily. But again, it's not limited only on a standard furniture. You can utilize this functionality more widely in various designs, because most of those designs nevertheless have some standardized components. So it's only on your imagination how to use it. Now, the following part of the presentation, I will show you the practical usage, practical creation of an iBox and how it can be used, However, it's not hands-on, it's not a tutorial, so if you are interested in more detailed explanation about how it should be done, what can be done in your real situation or your company, please leave your suggestions in the comment section or just contact your partners. Okay, so now let's see what should be done in order to make a new iBox. First of all, we need to set the right project in Inventor. Okay, so because iBoxes is like library components, we need to be sure that we have an access to the library folder, which by the way is dedicated for iBoxes. So we just switch the project in order to make it's possible to read and write to the library, and that's basically it. So we are ready to go. We are ready to make our new design. And as a design idea, I took this wine cabinet. So here we have quite simple mouth, which allows you to change the quantity of bottles, also change the amount of rows of those bottle holders, depending on the cabinet size. So we need to predict possible changes, what can be changed there, and place some efforts on the making this model a little bit more intelligent than it should be in a regular case. Yeah. So let's see how it happens. And everything starts from the skeleton design, so basically there is nothing new in comparison with what we do on a daily basis when we work with Autodesk, Inventor and Woodwork for Inventor software, so we are just starting our design. So what we're doing here, we're defining the size of a box, and we will place our components inside of it. Okay, so let's make this in the correct way, set the front as it should be. Now we need to add some parameters in order to control the thickness of the panels. Let's define the thickness value. Now we are ready to go. But first let's change the name of the first solid body, and later you will see that this solid body name will be used for the future components. So now we can make panels and then apply a trim command in order to control their intersection. What panel should be trimmed, what panel should be left? That's the question which is resolved by a trim command. Now, once it's done, we can just continue to work with regular Autodesk Inventor tools. In this case, I'm looking for a predefined sketch of a wine bottle. I will use it in order to see how much space I have in this cabinet. Okay, so let's place this bottle block here, make some adjustments, change the orientation. Okay, and basically that's what we have so far. It's like very simplified sketch of a bottle, but it will help us a lot because it allows to see how much space I have, what should be changed in my design, and so on. So here I can define some parameters like maybe bottle diameter and define the value for this diameter. Also I can change the height of the bottle and so on. So once it's done, we have some parameters which will be used in our math, in our expressions, in order to see changes when we change the size of our cabinet. Okay, so once it's done, it's time to define the supports, the holders of a bottle. Okay, as you may see here, I'm using the parameters that I have just defined. Okay, so let's say that those would be made from the same panel thickness as the case of this cabinet. Okay, now it's time to just set up some constraints and define the position more precisely. Okay, and this is nothing more than just routine design tasks as we face on our daily basis work. Okay, now it's time to change color a little bit by changing the layer, and it allows you to clearly see what is what here. Where is the bottle, where is the support, and so on. Okay, so now we can just change the view a little bit, add some more geometry in order to place the dimensions, because we need to define where this bottle will be resided. Okay, we have a pivot point, that's the point we can use like a rotation axis, and basically the question is how much rows of those bottles I can fit in this cabinet. That's why I need to know the vertical spacing for the bottles. Okay, and I'm doing this by just defining the dimension. Okay, like that. And now we can use this dimension in our equations. So it's time to finish the sketch in order to make some other components. Those are made like a new solid bodies. And as you may see here, we're just mixing the workflows. We're utilizing Autodesk Inventor functionality as well as the functionality of Woodwork for Inventor. Okay, so the names are important. That's why it's worth of spending some time on changing them. And once it's done, it's time to make some adjustments. Okay, as you can see, this structure reacts to the changes in the sketches. Okay, so let's see what we get so far. It doesn't look very detailed at this moment, but we will add detail as needed. It's time to add some parameters. We want to know how much bottles fits in one row. Okay, but we don't know the width of this internal niche of this box. But it's not a problem at all, because we can easily create a driven dimension, give it the name to this dimension, like so. Okay, and now we can utilize this parameter in our equations. Okay, however, we want to know, we want to define some minimal spacing, because we cannot just fit the bottles without spacing between them. So that's why we want to define some minimal spacing, which will be used in our equations. So if we know the width, we know the bottle diameter, and we know the minimal spacing between the bottles, so why not use them in our equation? Okay, we just divide the total width by a bottle diameter plus minimal spacing, and as you can see, there is some strange number, yeah, like 4 on 4. So that's why we need to utilize floor parameter, and what it does, it just takes the even number from this nominal value. Okay, so what we're doing now, we're defining the side offset, because we want to also have some spacing from a side. Okay, and this would be also calculated quite easily, because we know the width, we know the amount of bottles in a rounded way, yeah. So we know how much bottles will fit in this cabinet for sure, and we just multiply diameter by amount of those bottles in a row. Okay, minus some minimal spacing. Okay, like that. So there is very simple math. You will get the recording. You can just pause the record and see what actual formulas was used in this equation if you really want it. Okay, so once it's done, it's time to make another sketch, and we can use those parameters that we have defined in our design. Okay, but just say where the bottles would be placed. Okay, and there's the first one. We know the bottle diameter, we can divide it by 2 to get the radius, and we need to add some extra offset from the side, like minimal offset, and that's basically it. That's the place for the first one. So we can apply the constraints to fit in the right place. Okay, simple as that. And at the front we need to add another cutout. So let's do this in the same way by just drawing the sketch. In this case we need to draw 2 additional lines, make them perpendicular to the horizontal line, because as you can see they are tilted slightly. So constraints helps us to do this very easily. And now we want to make a cutout in this solid body. Okay, now we can make a pattern along one of the axes, and those patterns should be done sequentially, because we cannot do pattern in 2 different solid bodies. Yeah, that's the limitation of Inventor in this version. So let's do another pattern, give the part at the front, like that. So now it's time to define some more parameters, because we need to multiply those rows. Yeah, so we need to place multiple rows of those supports, And we need to define how much space at least we need to have between them and how much space we need to have at the top. Once we have those values, we need to define the quantity. We need to calculate how much rows of those supports will fit for sure in our space. Okay. Basically, we get all the things we need. We know the vertical space for the bottles. Okay, we can just calculate how much space we have, keeping in mind that there's some minimal distance. Okay, and once we have it, let's divide it by vertical spacing. Again, the number in the result is not very nice, so that's why we can just add the floor operator in the front. Okay, to get even number again. Okay, that's it. So basically we know that 4 rows will fit here. And what is interesting that we can see how it works on each moment of our design workflow. Without even making an assembly, we can check if this design works for us or not. Yeah, so we can just play with the parameters, see what happens. Okay, in this case, let's try to emulate the real situation. We know how much rows we will have here. And maybe you'll see that some adjustments will be needed. And as you can see, this design doesn't look very nice because the bottle will not fit here. Okay, so let's change the spacing between them, change the angle, and as you can see now 3 rows fits, and that's okay. But maybe we need to adjust the size of the front support a little bit. Okay, and here, as you may see, I'm trying to get rid of those constraints, but it's not easy to do. But locally, there is a lot of tools available in Autodesk Inventor which allows you to simplify this procedure. Yeah, so we can just delete some of the constraints, maybe even delete some portion of geometry, like that. Yeah, and then we can just change the size of the support by just drawing some new geometry and applying new constraints. So in other words, it's not important when you notice that something is wrong, because you can go back at each moment of your design and do the changes. Of course, if your design was done carefully with the regard of the possible changes. Yeah, and as you may see now, we have more clean looking design, which is very nice. Okay, you can double check if everything works correctly. And it seems that it's working nice. Okay, so we're basically ready for making the next steps. In this conception, for us, it's not necessary to make a patterns, yeah, because those patterns will be done in assembly level, not here, not in the concept. So we can leave this as it is right now and go for the next step. And at this next step, we will make a real assembly. Yeah. For those of you who are not familiar with Inventor, I can just describe it in a few words. Autodesk emulates real world. It means that we can have multiple parts and we can make an assembly from it. So that's what we actually are doing. We are saying that some solid bodies in our concept will be converted to parts, and those parts will be merged in one assembly. Okay. And what happens in the result? In the result, we have our assembly with all those parts. So we can just say where is the front, where is the main view, and so on. Basically, that's how our assembly looks like. And this is the second step in our design workflow. If you tried to do something with Woodwork before, you know that there is no difference. In fact, there is no difference in the workflow in comparison of what you are doing, except only one thing. You are working in the library. If you are working in the iBox library, that's basically it. There is no more differences here. Okay, now it's time to speak about the materials. So moving back here, we can assign some materials for our model. Okay, so we are going there, saying there is some material, a type that we need to use. In this case, it will be done from body materials. Okay, from the body type of the laminated board. Okay, that's it. we have material group set, and it's time to set some covers, which would be edge banding in this case. And I want to collect all the edges of the selected component like that, which will save a lot of time for me. So this selection mode works very nice. In this case, I want to select individual faces, so I can switch the selection mode and pick individual objects like that. And finally, we are ready to apply the edge bandings. Okay. Now we have materials set. Okay. At the next step, we need to add the parameters, because this assembly does not have any parameters which drives the amount of supports. So this assembly knows nothing about it, and we need to change this situation by linking the parameters of this assembly with the skeleton model. So I might just requesting what parameters I want to utilize in my assembly, like that, and we are ready to go. However, at this step, it's not worth of placing those patterns for one simple reason, because it's easier to apply a pattern when we already have the hardware placed. Okay, so that's why first we will place some hardware in our assembly, and later on we will apply the pattern. Okay, so how to apply the hardware? Basically, this is again the standard workflow of Woodwork for Inventor. We need to apply some additional geometry, which in this case would be work planes, and those work planes will define the place for the hardware items, which would be a minifixes in this case. Okay, some more work planes will be needed to fix the backplate and other components like supports. And if in future we will have some need to change the position of hardware, it's very easily to do. You can just move the work plane, and hardware related with it will also move according this change. Okay, it takes some time because we are doing everything from scratch. We're doing everything from the zero. We had nothing, and now we have something. And of course, later on, we can utilize all efforts that we put in this model in our future assemblies. Okay, so what we're doing now, we are going to a library to place some hardware items, like fixed joints, because there is a fixed assembly. And we have chosen a minifix to fix the components together. Now we can choose the configuration of this item if you want. Okay. And once it's done, we can place the items by showing where is the reference geometry, where is the nested boards, where is the pillar boards, and where is the axis, or work plates, in other words. Okay, let's place them. And as you can see, we already have some hardware on the place, so we can repeat this procedure again. In this case, we'll pick another set of geometry because we want to fix backplate, like that. So we can pick the work plates again. In some cases, it's a little bit hard to do in the modeling window. We can always choose them from the browser on the left. Okay, so basically, that's what we have so far. We have all the components on the place, but there is something still missing. We need to fix our supports. Okay, so we'll use the same idea here. We will try to fit this support inside of our assembly. Later we will see if it works for us, or maybe some changes will be needed. Okay, so we're trying to pick a reference geometry and say that we want to attach this minifix. Okay, and lastly, for the back support, the same procedure should be repeated. Okay, now let's see what we have here. Okay. As you may see, some of the hardware is not configured properly. We have some intersection and the wrong configuration of the hardware. So let's try to fix it. We can do this by moving reference work planes like that, but we will see that it doesn't help a lot, so some more changes will be needed. So still we have a dowel which is not flushed with the surface. So let's go back to our concept and do some changes. Okay, we have our minimal spacing. Let's increase it a little bit and see if it helps. Okay, let's save the changes, go back, update the assembly, and now we can see that those mini fixes perfectly works for us. However, it's not over yet. We need to make some of the components disabled and see what happens inside. Okay, maybe some of the hardware items should be changed. We can say that we want to change the configuration of the hardware like that. And now there is the tool called iMatch, which allows you to use some of the hardware like a template. And now we can say that those hardware items that we picked need to be exactly in the same configuration as the template is. Okay, and it doesn't take a lot of time, just basically a few clicks away from the final results. Okay, that's it. Looks quite nice. So now we make components enabled again. Okay, and we can switch the representation mode, the visibility mode, to see if everything works as it expected. Okay, now it looks that there is no more problem, and we can just return the view style to default one. Okay, so now it's time to hide those work planes, make them invisible, and that's basically it. When we have all the hardware on the place, we can just mark the components with the hardware and then make a pattern. Okay, so we can just say that we want to multiply those supports with their holders like that. How much of those holders we must have is defined by a formula in our concept, so that's why we're just getting those parameters that we have calculated in the previous step, and that's basically it. So as you can see, we multiplied not only supports but also the hardware that keeps them in place. Okay, now basically we did everything till this moment in the same way as we do this in a normal workflow with Woodwork for Inventor. And now there is the difference. In order to make this model to behave like an iBox, we need to apply some publishing procedure. Okay, so what we need to do here? We need to apply some constraints, some imates, which will be used on the moment when we place this hardware, when we place this iBox with the hardware and materials in our concept. Okay, so we're saying where would be the top, where would be the front, and where would be the side of this model. Because again, it depends on your design, what you're really making. Okay, so we defined where the front, where the top, and the sides would be. And now the next step is to say what file controls this model. So we are saying there will be a skeleton, and now we're mapping the parameters. We can say what of the parameters changes the width, depth, and the height of this model, as well as what imates are used for positioning, where is the front and where is the top. And basically that's it. So we define this object as an iBox. Okay, and as you can see, the iBox making time is very short. In fact, it took like maybe 5 to 10% of your total design workflow, maybe even less. It may take 10% in case if you are applying some logic. If you are placing iLogic rules inside of this iBox, then yes, maybe you need to think a little bit. about how it should behave, but basically the idea here is that iBox definition is just a fraction of total design workflow, normal design workflow that you usually do with Woodwork for Inventor. Okay, so now let's change the project back to the standard one, like so. And we need to make a new assembly. And we can just place our concept inside of this assembly. Okay, and once it's done, we basically are ready to go with the iBoxes. Yeah, so as you may see here, we have a kitchen layout, which is very basic and just set of boxes. But again, it's not limited on boxes only. You can design probably any design you want, any shape you want, and utilize it like a box element. Okay, now let's see what I meant by saying layout. So what this layout can be. Basically, it's a single part made like in a multi-body workflow, have multiple bodies inside, and those bodies represent the position of some components. Okay, here I'll have a table, here I will have the desktop, here I'll have some cabinet cases and so on, and later on I will put those iBoxes inside of this element. Okay, so this is basically just a set of multi-body parts. And as you can imagine, it can be done very easily. It does not require a lot of time, but you can discuss with the manager about if it works okay, or maybe some changes needed to be done on this conceptual level. Okay, so now let's see how the iBox can be placed in the right position. We have our concept model with the topology layout, and now we just need to save it in our folder. Okay, let's give the name to the file, define the place where it should be placed, like that. Okay, so that's basically half of the work done, and we need to go for iBox insert option, find our newly created wine cabinet, say what the naming scheme would be, wait till this moment is copied in our workspace from the library, because we want to leave our model intact, so we need to have a copy each time when we use it, because it will be changed in the size. And once it's done, it's enough to just select some of the object, some of the reference geometry, say where is the front, the top and the right side, and that's basically it. As you may see, our iBox nicely fit into the place. However, it may turn out that some changes needed, and we can easily went back to our concept, make those changes, and then go back to see how the model reacts to those changes. Imagine that for some reason we need to change the size of the cabinet on the very right. Maybe we want to utilize it not for the fridge, but for something else, maybe for some tall wine cabinet here. Yeah, so we can easily do the changes by defining a sketch dimensions on a very low level on our concept, on our very first step. And as you can see on the left, the spacing for this wine cabinet have been increased. So we can just say that we want to update the iBox, and that's basically it. As you may see, now we have wider cabinet for the wine in a few clicks. Okay, now let's speak about the benefits, what we get using this workflow. So first of all, iBox usage allows us to focus more on a concept, utilize concept, and then place the details from predefined components. It allows you to rapidly make various prototypes without putting a lot of efforts on it and without wasting a lot of time on it. If there is a need to make some changes, it can be done easily without any problems, as you saw already. And because those models can be refined before the usage, you can be sure that there will be no mistakes. Yeah? You already defined this cabinet, you assign the materials, place the hardware, define how it behaves, and it repeats its behavior again and again. There will be no surprises for you, no negative surprises for you when you will utilize it. Okay, of course, those components can be placed into the shared place, utilized like a shared library for all of your company members. And if there is a new person, new designer, it's way easier to start work with this designer, because the iBox requires lower skills than it would be needed in case if this designer must design something from scratch from the very beginning. Okay, when this apprentice will get some skills, then it can do his own iBoxes, but for the very beginning he can already use those predefined, checked, proven models to make high quality assemblies. Okay, and there is some questions we get from our clients. Let me discuss those with you. Often we get a question, what can I do if I want to design something more than rectangular furniture? There is basically no problem, because what the iBox does, it just took the parameters of the place where you want to fit it and then send those parameters to the skeleton file. Okay, so what you would do with those parameters completely depends on your design idea. Yeah, it's up to you what you will do with that. So the shape can be various. So how hard is to convert existing model to iBox? You saw already that it doesn't take a lot of time, just a few minutes and that's it. So basically each model which was designed using standard top-down design methodology of Woodwork for Inventor can be easily converted to iBox. How you can modify it? You can just change the project, change the parameters. Maybe you want to copy existing iBox and maybe do some changes on existing model. It's completely doable without any big efforts. Do you need to have some programming skills in order to make the iBoxes? As you saw already in this example, I haven't used any programming. However, next question is, what if you have the skills in the iLogic, if you have the skills in the programming, can you utilize them in iBoxes? Absolutely, you can use them if you want. If you feel that there is some logic needed to be placed in your models, feel free to do this. Okay, so that's basically was all information I'd like to share with you today. Thank you very much for your attending. Good luck. Bye bye.